I'm very happy you made it to the talk, and so many people made it. Welcome again. And today we're going to talk about test gap analysis. Many of our customers are facing the problem that they have to test ever more functionality in less and less time. And if you face the same challenges, you're in good company. These are the logos of all the companies that joined the talk until last week. And I think you can see from all the different logos and the different types of companies that we have, that this is not a problem that we have to test more and more functionality in less and less time, that this is not a problem that is specific to one domain or one programming language or technology or one way of making software. But rather we see that this is almost a universal problem that every company at some point faces. We add more features to our software and we try to do development faster, and thus there's less and less time to test everything that we do. And today we want to show you how test gap analysis can help you tackle that problem. My name is Fabian Streitl. I've been working with test gap analysis for almost 10 years now in different roles, both getting it set up for our customers, as well as consulting on how to use the analysis properly. And now I'm team lead of the team that we call Test Intelligence, that cares for all the different analyses that we provide for testers, including the test gap analysis. And I'm going to show you in the first part of the talk today a little bit about the theory behind the test gap analysis and the motivation. Why do we want to do it? How does it work in general? And then in the second part, Raphael, my colleague, will show you a bit of the technical details and also go into some practical examples how our customers are applying the analysis in their settings. And then in the third part, my colleague Andreas will give you a demo so you can see what it feels like to actually use the tool. And then in the final part, I will come back in and I will give a little presentation on a cost-benefit analysis that we did with one of our really good customers. I think people from MunichRE are also here today because MunichRE was using the test gap analysis for a long time and they wanted to know what kind of benefits did we actually realize from using it for several years now. Before we go into the topic, I want to have a few words about our company because I don't know how well you know us yet. We are CQSE. We are located mostly in Germany. We're a spin-off from TU Munich over 10 years ago. So our headquarters are in Munich, but we have offices and home offices all over Germany. And since a few years, we also have a permanent office in Sunnyvale, California, in the Silicon Valley to serve our customers there. And we make the tool called TeamScale, which runs the test gap analysis and some other analyses as well. But today the focus is on the test gap analysis. So far, so good. Let's jump in. So we all realize we have limited time when we do testing and usually too little time. And so the big question for us testers is always, how can we get the most out of the time that we have? How can we spend the testing resources that we have most effectively? And in practice, this means how can we find the most bugs in the given time? And there's actually a lot of research on this topic. In research, this is called defect prediction. So you give me a software system and I tell you where all the bugs are hidden. And if we could answer that perfectly, then testing would be really easy. But unfortunately, in practice, it's more complicated, of course. But there are some interesting insights. And I think the main insight from several years of defect prediction research and several hundred studies that were done is that for software that we have to maintain for a long time, most bugs are hidden where we recently made changes. And now you're going to laugh as experienced testers and say, well, I already knew that when we make changes to a software system, that's risky, there's probably bugs. So we have to do a comprehensive test of all the recent changes. For example, everything that happened in the last sprint or everything that we did for a certain release. And that makes total sense. And actually, people already usually try to structure their testing in that way and do risk-based testing by looking into these kind of tools. So these are issue trackers. These are examples from our own past. So at the moment, we're using Jira, but before, when we were a very small company, we just put some stickers on the whiteboard. We also use Bugzilla at some point. Doesn't really matter. In the end, these tools just record what the developers did in the source code for a certain release or for a certain sprint. And then we as testers can go through that list and look at every issue in the issue tracker and decide how can we do as comprehensive a test as possible for the changes that were done there. And that is a good idea in theory, but in practice, this approach has some limitations. And to show you the first one, I'm going to go into a study that we did on our own code, where we looked at about 2,000 issues from our own issue tracker and categorized them into these 4 well-known categories. So perfective means these are the new features. Corrective means those were bug fixes. Preventive means that we were doing something to make future maintenance of the system a little easier. So things like refactorings or restructuring the code or changing something about the architecture to make it easier to maintain the code. And adaptive, the last one, means that something outside the system changed. We updated the OS version, or we had to change a driver, or we had to upgrade a library, and we have to adjust our code to make sure that the system still works. And if you think about these categories, for the 2 on the right, it's pretty clear what I as a tester have to do if I'm doing a black box test to make a comprehensive test of the feature or the bug fix. Because in the bug ticket, I have a steps to reproduce. I just go through the steps. If the bug doesn't happen again, it's probably fine and the ticket is tested well. For a new feature, I have a list of requirements and I can go through that and decide if the feature was implemented properly. So those are easy, but for the ones on the left, the adaptive and the preventive changes, it's much harder for us as testers that don't have a white box perspective, but a black box perspective to do a comprehensive test. Because which code areas do I have to, which things in the UI do I have to trigger to go through all the code areas that were changed because we upgraded our logging library or something like that? I probably don't know. And that makes it really hard for me as a black box tester to know what I have to do a really comprehensive test and get to all of those code locations that were changed in that issue. And for us, those kind of changes made up almost 15%. So that is a reasonable number of issues where we have difficulties making a comprehensive test. That is problem number 1, but that is the smaller of the 2 problems. The much larger problem we face as testers is not everything that the developers do on the code level, not all of those changes are actually documented in the issue tracker. And there's a wide variety of reasons. It starts with simple things like the developer implements a feature and they notice that they have to reuse some code, so they do some refactoring, but usually nobody writes these small refactoring changes into the tickets. And then in the end, as a tester, I don't know that more than just this feature was changed, but rather some other features were impacted as well. And it can go to more complicated scenarios. We had one customer where there was a lot of pressure on a project and they were only allowed to implement the highest priority of tickets. Everything else was forbidden. But somebody from sales knew a developer very well, and they had already promised a low priority feature to their customer. So they just sat on the developer's lap until the developer agreed to implement that low priority feature. But of course, nobody wrote that in the issue tracker because then the developer would get the blame. Why did you implement this low priority feature? And so for a lot of different reasons, some well-intentioned, some not so well-intentioned, different kinds of changes make it into our software that we release that the testers never even get to know about because they're not recorded in the tickets. And so together, this makes it really hard for us as testers to do a really comprehensive test of all the changes that the developer did on the code level. And this is, of course, all gut feeling so far. We wanted to know how much is that actually in practice. So how many things that happen on the code level do not get tested at all during a test phase. So we did a study with MunichRE, a big reinsurance company here in Munich, on a C# system of theirs, where we looked at 2 releases. And for both releases, we looked at what code was changed. This is the left bubble in this diagram. So this is all the code that was touched by the developer, either new code or modified code. And we also looked at all the different test stages that they have and checked whether, sorry, I said it wrong. The right bubble is the changes, the left bubble is the test coverage. So all the different tests that they have, we checked which code is getting executed during those tests. And then we also know what code was tested and what code wasn't tested. And we did this for 2 releases. And we did this for all the different kinds of test stages that they have. So starting from unit tests in a pipeline, up to automated UI tests, up to manual tests via the UI. including all of those pages. And for both releases, the developers changed about 15% of the code of the system, and over half of the changes that they made it into production completely untested. And that's not because MunichRE has such a bad approach to testing, but rather the opposite. They have a very structured testing approach. They do exactly what I said. There's test analysts going through every single ticket, deciding what do I have to do to make a comprehensive test of the changes described in the ticket. And still, over half of those code changes make it into production completely untested. Now, the second part of the study, we looked at each production defect for those two releases that was reported. And we sat together with developers and debugged which line of code caused the production defect and from which of those areas here did it come. And this was the part that was not so surprising. It's 5 times more likely that the production defects are caused by one of these untested code changes than any other part of the system. So in summary, not only do a lot of the changes that we make on the code level make it into production completely untested, they also cause the majority of production defects. So in other words, wouldn't it be great if we knew where these untested code changes are before we make the release, so that we can still react as testers and maybe schedule some additional tests to cover those risks? And this is also what MunichRE told us at that point when we did the study, that it was nice to know that they had so many production defects and so many untested code changes, but it would be much nicer if they had known earlier on. And this was when we got the idea for test gap analysis, which is trying to show you before you do the release where the untested code changes are so that you can address the risks. How does that work in principle? We need 2 pieces of information. On the one hand, of course, what changed in the software system. This we get from your version control system. So there, when your developers check something in, TeamScale can already know what changed in the software system for a release, for an issue, and so on. On the right side, we also need to know what happens when you do tests, both in your pipelines and if you do manual tests in some fashion, or automated tests or a dedicated test environment. We need to know which code is getting executed during those tests. And for that, we use so-called coverage profilers, which are little tools that instrument your application so that we get to know which methods are being executed while you do your tests. And when we have these 2 pieces of information, TeamScale does the rest. It combines them and shows you the untested code changes in real time. To give you an idea what that looks like in the tool, I have to introduce a visualization that we like to use for that. It's called a tree map. It's basically like a map of your software system. Every big rectangle you see here is a component in the software system. So in this case, this is the business information system. So where is your mouse? Here. So this could be something like UI controls, and over here could be some authentication code for a web application and so on. These are the different big components. Now what I'm going to do is I'm going to zoom in step by step into each of the components. So every black bordered rectangle that you see now is a class in that component. And if I zoom in one more step, then every rectangle now is a method in that component. And still, if the methods are close together in your version control system, so in the same folder, in the same class, and so on, they're also close together in this visualization. And the more lines of code are in those rectangles, in those methods, the bigger the size of the rectangle. So up here, we have a rather large method, and down here, we have some small ones. And what we can do now is we can color each rectangle. This is the dimension that we still have left to provide additional information. And we color the rectangle depending on what the analysis thinks about the method. Let's start with the code changes. So now every rectangle that is gray has not been changed since the last release. And if it's colored, then it has been changed. So either it's completely new code, then it's red, or the code was already there at the last release, but somebody made a modification, then it's orange. We can do the same for the test coverage data that we have. So now gray means this was not executed during the tests, regardless of the test stage. And green means in one of the test stages, this method was executed. And then we can, I already said this, we do this for manual and automated tests, and then we can combine these two pictures to get the test gaps. And now here, gray still means this is unchanged. So this is all the code where the developers didn't make any changes since the last release. This is where the rate of production defects is rather low, and we can expect not many bugs in there. So the interesting code is everything that has a color. And because this is all the code that the developers touched for this release. And only if the latest version of a method was executed during a test, then it becomes green. So in other words, everything that is red and orange here, so these large blobs here, this is the interesting stuff. This is what we want to look at with the analysis, because these are the test gaps. We changed code here, but we never executed those changes during the tests. So if there's bugs in there, we can't have found them yet. And there's actually a large chance that there are still bugs in there. So it makes a lot of sense. If you imagine you get this kind of picture for your own system, it makes a lot of sense to drill into what are these components, why did we change code here, what kind of features were implemented here, and do we need additional tests because maybe we forgot that some changes were made here. Is there a question?
No questions so far. So if anyone would like to speak up through the mic, please be welcome now.
So what tool did you use to picturize all the code that was covered and uncovered?
You mean make these pictures?
Yep.
This is TeamScale, so our own tool.
Oh, okay, okay.
We'll also see it in the demo later on.
Otherwise, I currently see no questions, so let's move on, I guess.
All right. So let's again imagine you get this for your own system, such a picture with all the, and you know where all the untested code changes are. What do you do next? What we need now is we need to find out what are these areas of code, why were changes made, and are these a risk that we need to test or not? And okay,
sorry for interrupting. Just because we before we jump into that, there's actually one more question just popped up in the chat, and I think it's relevant before we dive in. So what does tested actually mean in this context?
Yes, very good question. Thanks a lot. So we always say here executed during test, because we can't know from just the coverage data that we get whether a method was tested well or not. So we only know it was executed. We don't know if there was an assertion or somebody was looking at the relevant parts of the application that were influenced by that method. So it could be that there's still bugs in the green methods. We can't say that for sure. So these are actually, we know less about the green methods than we know about the red and orange methods, because about the red and orange method, we for sure know that we haven't ever run through those in the tests. With the green methods, we just know we ran through, but we don't know how well tested they are. Which is why we always put the focus on the red and orange.
Okay, now the questions pop in. Is there something planned to also cover branch testing?
I assume if you mean branch testing, if you say branch testing, that you mean people are not just testing on a single branch, like the master branch, the main branch, but rather on many different branches. And yes, that is also supported by the tool. We'll get into that a bit later in the talk.
Okay, if that answered the question, if that did not answer the question, please elaborate.
Yeah.
Or just speak up.
Anything else?
Okay, so currently we're out of questions again. So
one quick question.
Yeah, sure.
In this TeamScale, I guess we will get to know the test coverage, right? What we have made changes or the old test cases, if we have not completed the test for the old code, or which is not covered, which will be in the gray zone. So my question over here is that the green portion ensure the quality of the test cases as well? But like if we cover the test cases, doesn't mean it's covered well, or it has the good the coverage of the test cases. It might be just we have written some test cases which is not useful for that, but we'll get in green and we'll be using this team scale, will be in a dilemma that it's covered, so we don't need to worry about it. And probably we covered a very bad test cases for that code. So like are we going to ensure the quality as well of the code?
So
what we have tested?
Thanks a lot for the question. I think this is very relevant. So I think this goes in the same direction as the question before. We don't know anything about the quality of the test cases in this analysis. So with test gap analysis, all we know is that we executed the code, but we don't know if the test case was well designed that executed the code, or if somebody just clicked through the UI and didn't actually look at anything. This makes no difference for this analysis, because we want to focus here on the most risky parts of our system, and those are those where we don't have any test cases at all, the red and orange. So we don't really care how well written the green parts, the tests for the green parts were. We care about why we don't have any tests at all over here in these large red areas. This is what we want to uncover. TeamScale has different analyses that can help you ensure high quality test cases, but these are out of the scope for this talk. But if you're interested in that, we can also maybe in the breakout rooms afterwards talk a bit about it, what we can do there.
And we also have a workshop on that actually coming up in a month. So I'm happy to send you the invitations. Meanwhile, there's actually a clarification on the branching question. Coming back to that, he meant not branches as in different branches in the version control system, but branches within the program logic. So within the methods.
Yes, also excellent question. So what we see here in this view is what we call method coverage. So we only know whether the method was executed or not. If the coverage profiler that we use to record this coverage can also give us more detailed coverage, which most profilers can, then we can also drill down into these methods to view line coverage and branch coverage, and maybe even more complicated coverage measurements like MCDC coverage. So the tool supports this. We can also later on show a little bit how this works in the demo. But for the test gap analysis, we like to focus on the method level, because usually there's so many areas that are red and orange where we don't have any coverage at all, that we are already spending a lot of time on getting those covered, that there's usually not that much time left over to look into every single method and decide whether the branch coverage is okay or not. So I mean, in the end, we come from the premise that we have too little time for our testing efforts and that there's too much stuff to test. So in the end, we probably won't have time to drill into detailed branch coverage for all of the methods, but usually there's like a few different very important parts of the system where it makes sense to drill a bit deeper and do an inspection if the branch coverage, for example, is as we want it or not.
Okay, that seems to have answered the question. My apologies for not phrasing that correctly in the first place. So thanks for the clarification.
Can I have a last question? Sorry.
Yeah,
so,
sure.
Fabian, one question. So this picture also shows us the coverage of the UI tests, or only this is the unit tests that are being done by the developers?
So in this case, this is a combination of all the test stages that they had at that time. I think back then this was unit tests, some sort of integration tests, and manual UI tests.
Okay, so other question. So those tests, I mean the automation tests, are on the same branch, or they were combined from, for example, from two branches? One branch is the code, and the second branch is the UI testing, or how was it? I just want to know the architecture, how it was done.
So I'm not sure what you mean with different branches here, because for this concrete picture, they did at that point in time not use very many branches in their version control system. So I think they had like a main branch where the development happens, and then just release branches for the different releases. And the tests for the unit tests were run on the main branch, and the tests for the manual UI tests were run on the production branch, the release branch.
Okay, okay.
So I combine these two.
I mean, do they have a mono repo, or do they have separately separate a project for tests? Do they have separate project for the application and so on? Or this is everything unified in mono branch, mono repo?
So in this for this application, they have a mono repo, but we also have customers that have like multiple repos when they do like microservices or something like that, and every microservice has their own repository. Regarding the tests, we don't really care where the test descriptions or the automation scripts and so on are stored, because we don't analyze those. We analyze the application as it's running with the coverage profiler, and it doesn't really matter where you have your automation scripts stored, because we don't change those. Does that answer the question?
Yes, completely. Thank you very much.
Oh, you're welcome. Thanks for the question.
Thanks, everyone. And looking at the time, I think we should move on now.
All right, will do. So let's get back to this picture. We come from that we have this overview over the test gaps for our own system. How can we interpret it? And in our experience, it needs different roles to make heads and tails of these rectangles. And that's on the one hand, the developers, because they know what code changes they made and why. And on the other hand, the testers, because they know which tests they already ran and which tests are still being planned. And then together, you can decide whether such a big red component is a problem, because maybe somebody forgot to write something important in an issue description and the testers didn't know they have to test this. Or maybe it's not a problem because we're halfway through the testing phase and the tests for this component just haven't been run yet and will be run next week. But either way, you usually find some areas where the testers did not know that they have to test something. So you plan additional test cases or you modify your existing test cases a bit. And when you do that and run those test cases, because we set everything up to be fully automated, when you run the test cases, we get this new coverage information in team scale and the test gap analysis runs, and then you get an updated picture here. So what you can do now is, while you're doing your testing, step by step, you can run around this feedback loop and always have a look what test gaps are there still, which ones are a problem, adjust your testing behavior, and then see if that actually closed the test gaps and made them green or not. And you can do this until you're satisfied and make the release. Now, two important caveats. I think we touched on most of this already, but I want to emphasize this again because this is very important. The goal of the test gap analysis is not to have everything green at the end, because usually there are some areas where it doesn't make sense to expend a lot of test effort to test some minor things. Some examples are very hard to test code, like some failure recovery mode that you can't manually trigger, or maybe some very trivial changes, like somebody changed the button color from green to blue, and if that didn't work, then that's not the end of the world, and it doesn't really make sense to spend an extra test cycle just on that. So the goal is not to have everything green, so 100% change coverage, but rather just to give you the transparency and allow you to make this risk decision. Where are the most, the biggest risks that we still have to cover with our testing? And then when you cover those, you can be happy and make the release. And on the flip side, 100% change coverage, so everything green, would also not mean 0 bugs. We already touched on this. For the green methods, we only know that we ran through those methods. We don't know how well the test case was designed that ran through there. So we don't know how well tested the method is. So we can't ever guarantee 0 bugs. This is true for any kind of testing, and test gap analysis doesn't change this. On the flip side, we still know that all of the red and orange methods, we can't have found any bugs in there. So those are the areas we want to focus on with the test gap analysis. So far, so good. Now I would hand over to Raphael for some practical examples, unless there are some more urgent questions we want to slot in. Sven?
There's one coming in. How do you acquire the data for test cases that are done via manual?
Via manual testing?
Sven's audio is gone, but I was the one who asked the question. So yes, basically, you mentioned that if some tester manually tests something in the GUI, that the TeamScale will be able to mark those methods that are tested manually as green or tested in the overview. How do you acquire this data, and how does it reach the TeamScale overview?
Very good question. Thanks a lot. So what we use is a so-called coverage profiler. This is an additional tool that you install alongside your application on your test environment. So I'm assuming you have a manual test environment where you install your application and people can then, for example, go to web interface or use the application some other way. And we install our profiler next to it, and it will instrument your application while it's running. So whenever a method is called inside your application, this tool will get notified and just write it down, basically. And then later on, send us a report of all the methods that were executed. And then we can use that information for the test gap analysis. And this profiler, it doesn't care how the methods are being executed. So whether that is a unit test calling the method directly, or whether that is you clicking on a button and the button click then triggers the method. It doesn't really matter. We just report that the method is being executed.
Okay, thanks.
You're welcome.
Okay, I hope my audio is back now.
Yes.
There's another one which is on the longer side, so I hope I can read this out while reading it. How do you check the side effects of changes in basic classes? So maybe we increase the Java version, or maybe we have an extension of scroll view that is used everywhere in the application. Of course, we will test the feature that use this new feature of the new Java version or the new scroll through, but how to identify the areas of the application where our code is unchanged, but might be affected by this update?
Also an excellent question. So I think we're touching now on the limitations of the analysis, because if you change something outside your application that doesn't require you to change your own code, then the test gap analysis obviously doesn't notice that, because we only look at code changes from your own code. On the other hand, usually when you do a larger upgrade, then you also have to do some code changes in your own application, because maybe the API of the scroll view changed and you need to adjust to that to make your application compile again. Then test gap analysis sees those changes you made in your own code, and you can use the test gap analysis to make sure you cover all of those. So it doesn't, unfortunately, not solve all testing problems, but some of them. And one thing that sometimes happens is that you have in-house dependencies. For example, some other team is providing you that implementation of the scroll view base. Then in that case, we can also, since you also have the source code from the other team, then we can also use that for the test gap analysis and combine the information from both of these projects. So in some cases, we can help in that scenario. In other cases, we can't.
I hope that answered the question. In the interest of time, I suggest that we move on. So for everybody else, if you have questions, we will get back to you. In any case, we have even time after 12 o'clock if we want to run over and answer more questions, or we will arrange something to answer questions later. So don't worry. We will answer your question in any case, but we'll continue now in the interest of getting through the content in time. So Raphael, stage is yours.
Okay, thank you. All right. So I will now show some practical examples that we actually observe at our customers. But before I get into that, a quick technical overview of how this works on the technical side. So we need two types of data, as Fabian already mentioned, the changes and the test coverage. For the changes, TeamScale directly connects to the version control system, which means it gets all the changes from every single commit. So TeamScale runs as its own server, so not in the build or something, and connects to the version control system and retrieves all the commits. That's for the static side. The dynamic data, so the test coverage, as Fabian already explained, we get from profiling the system under test. This can be done with a variety of tools for different languages. For example, Coco for Java, GCAF for C++, and so on. So there's a variety of tools here for different languages that we use. And these tools then provide a report that usually, when visualized, looks something like this. So we have some lines that are covered here, marked in green. We have some lines that are sometimes partially covered, depending on the profiler. We get this partial coverage where, for example, one branch is covered. And then we have lines that are not covered in red here. And TeamScale then combines these two types of data, as already mentioned, and this results in the untested changes. In most real-world systems, we have more than one type of tests. So, for example, here we have component tests, also, or unit tests, which test like one single class or one single method even of a system. Then there are integration tests, which verify that the components work together in the way that it was intended. And finally, we have the system or UI tests at the highest level, which test basically the whole system when it is actually deployed. And TeamScale can aggregate, or in TeamScale, you can aggregate or select between these different types of tests. All you need to do there is specify what type of test data it is that you are giving to TeamScale when you're handing it over, and TeamScale then can arbitrarily, or at runtime, you can select which type of test data you want to see, or if you want to combine them all. Okay, now for the scenarios. I brought 3 different scenarios, which in practice we often see at customers. And the first one is a hotfix test. Probably most of you are familiar with this. So we have found a little mistake in the source code found by a customer. The bug was fixed very quickly because it's a critical part of the system. And then we want to retest it to make sure that we didn't introduce another bug with this fix. So what an example of what this can look like is here. Here we have an SIP system, and bug was fixed. And we can see that in red, we have some newly introduced methods, and in orange, we have some changed methods. And what I would do here as a tester now is probably first read the issue description, see how the bug is reproducible, and just do what caused the bug in the first place and see if it still appears. After doing that and retesting the bug, we have this picture. So part of the methods were executed, but not all of the changed methods have been covered. In this case, the framework forced the developer to also implement some edge cases that were not exactly described in the ticket. So he had to do some additional work that was not documented. And yeah, this happens quite often, that changes are not explicitly stated in the ticket or are not even explicitly part of the bug. Same is valid for feature tickets. Often there are cases implemented which were not specified in the ticket just because the developer noticed that there are some corner cases or there is some additional small things that would be nice to implement there. And the TGA now, or the test gap analysis, now allows me to make an informed decision on whether these changes should be tested or not. In this case, the tester then talked to a developer, and if a test for those uncovered methods was necessary or not. And in this case, they decided it is relevant enough to get its own test. And after they performed this additional testing, it looked like this. And this patch was actually published for the end users then. All right, for the second scenario, this is also something most people are familiar with, I guess, which is a release test. So we have a very simple mental model here on the slide. First, we have a development phase, which takes quite long, maybe several months. Then there is a big test phase. In between, there is some kind of code or feature freeze. So either there are no more changes made or only bug fixes made after the development phase. And at the end of the test phase, before my release, I would like to know, did I cover all my changes? Is everything tested well enough, or are there any big gaps in there? And for this, I'm reusing the example that Fabian already showed before with this C# system, about 1.5 million lines of code. And for the release, 30 developers have been working for about half a year. Also,
they already specified manual test cases when writing the requirements, writing the tickets, and those manual test cases were then handed over to a test factory in India, which then performed the testing. So testing took a few weeks, a lot of test sessions, and it also spanned different versions of the system, because they already implemented some bug fixes, then handed over the new version of the system, and the tests continued on that new version. In TeamScale, these different versions are automatically combined, and you always see the latest state. So the tree map here is the one you're already familiar with from Fabian's part. As usual, in orange, the changed methods, and in red, the new methods. Here we have the test coverage again. Also, you've already seen this part, and then the final test gap picture here. And this, what you don't know about this yet, is this was actually on the last day before the planned release. And what you can see, especially in these areas, is that there are tens of thousands of untested lines of code. And these areas that are marked here with the arrows now are basically not tested at all. And yeah, what we found afterwards was that this was somewhat of a communications problem. So originally this project should get an automated test suite, but the project for that was actually canceled. And so none of those automated tests were ever run. The problem then was that they had no manual tests specified for those areas. So those manual test cases were never handed over to the test factory in India. And so no tests were performed for these areas almost at all. And we only have few small green bits in here, and the rest is all untested. So what they actually did here was they moved the release back and performed an exploratory test or monkey test, where the actual users of the system go through and test the requirements as quickly as possible. And also this took 2 additional weeks, over 307 test sessions and different versions, as similar to what we had before, but this time including the requirements for those new features. And here we have the picture of the changes, almost the same as before. And now the test coverage. Here you can already see we have quite a bit more coverage, a lot more green here than before. And this also shows in the test gap tree map, a lot more is covered here. We still have some uncovered areas. 3 of those we looked at in detail, and yeah, looked at why they were still uncovered. On the top, the arrow, those were areas that were actually statically unreachable at this point. So it was essentially dead code. In the middle, there was functionality that was prepared for a future release, so not yet relevant for testing. And at the bottom, this was actually just missed functionality because nobody in the system, nobody ever got to that point in the system. So it was just missed by tests. All right, this big view, this big release test view is good for someone who's responsible for the testing of the whole system. And also, if tests are performed a few times a year, then this view is really helpful to give me an overview. But what we see more and more is that teams are developing in a different mode. Development is happening in a lot of places. Testing is happening as well. For example, if you use feature branches, every feature gets its own branch, and every bug fix gets its own branch, and development and testing is happening on those branches. So what often happens is that the quality assurance happens on the branches before the merge. And so now, as a tester, I don't care anymore what the whole system looks like. I mostly care about what happened on this branch or for this one feature or bug fix. What methods have not yet been tested there. And I want to focus on this smaller scope of the ticket I'm working on and not the rest of the system. And to deal with this, we mapped the test coverage to tickets, or ticket here means a description of a unit of work in an issue management system, like, for example, Jira issues or Azure DevOps work items. And what we have here now is, with this support included, a screenshot from our own development. So here you can see the different issues. And on the very right side, you can see what percentage of methods have not yet been covered that were changed in the ticket. And if we click on one of them, we can see a more detailed view, and we can see this tree map now, which only includes the methods that were changed for this ticket. And I can immediately see which methods are not yet covered here. And I can also, for example, see the creator of the ticket and the assignee, if I have any questions, if a method needs to be covered or not. And yeah, I can talk to them if needed. A guideline we use here actually is that the reviewer checks for non-trivial test gaps before merging. So any code change that is rated as non-trivial should be tested before the branch is merged. All right, for this additional analysis, we need a little bit more data. So on the one hand, we need to connect to the issue tracker to actually get the issue data. So Jira, Azure DevOps, or also GitHub, whatever you're using. And TeamScale reads that. And in addition, we need to have the ticket number somewhere. So either in the commit message, as for example, here we use it at the start of the commit message. There is always the ticket number. The other option is to include it in the branch name. And with that, we can then, TeamScale combines all of this data and we get the issue test gaps. All right, that would be it for the practical examples. Are there any questions at this point?
None so far, but maybe let's wait another couple of seconds for people to process all the different scenarios and come up with their questions.
I have a question.
Sure.
First, thank you for the example. I wanted to know if how do you decide after you see the tree map if something is dead code or impossible to reach or not testable? Is this a manual process or can this be automated, and if so, how?
Yeah, this was in that case included in a study, so it was a manual effort there to actually look into the code with the developer and check if this is dead code or was just not reached and so on. So yeah, for these parts, we cannot yet automatically do that. What we have actually done before is have test coverage profiler attached to a real application when it's actually running, so in production, and then look at what parts are never executed. And those are, of course, it's suspicious that those might be dead code or at least unused for like a year of actual usage. But yeah, that's also not definitive dead code or something. It's just that it's not used in practice for quite a long time. But beyond that, I think we cannot do any automated detection of statically unreachable code.
Thanks.
But in general, I think you are able to do like static code analysis, right? Because I know that we are currently doing that, and we have some issues then if we have some pull requests and there's some unreachable code detected by the static code analysis.
Yeah, sure. Static code analysis is part of the tool, not scope of this talk, but yes, we do static code analysis. But unreachable is always difficult to say because it could also be called from some outside code or something, which we just don't know all the parts. Or if, for example, you have a REST API and then we can't say is this REST endpoint ever called or not, and so on. So there might be that code even that it's just not easy to detect.
Yeah, especially if we talk about entire features being unreachable. It's a different scenario whether I look at individual methods or classes, or whether I look at an entire feature where some developers or a product owner can tell me, okay, the feature we discontinued by the last version, so we know the code is irrelevant by now. That's knowledge we cannot have in the tool.
I have another question, if it's okay.
Of course, sure.
Thanks. So another question is, does the untested code changes, do they carry over to the next tree map that I would produce after pushing my changes and then changing them again? Is there carryover?
Yes. So basically, this tree map is you select the tree map for a certain time interval, and it's updated after every commit. You will also see that in the demo, actually, that is coming up right after my part is done. So the tree map basically updates after every commit. And if something was tested, but you made changes to it afterwards, then the tree map knows that. And if you, the tree map updates accordingly when you reload the site. So the tree map is constantly kept up to date.
Okay, thank you very much.
Yeah, there's another question, and I'm not sure if I missed it or if that actually exceeds the scope of that talk anyway. But the question is, you need the test coverage now for each and every branch, which might be quite some effort if you have a huge test suites. And I know that somehow I think you're working on this, but would it be possible to configure it in a way that automatically only the tests are being executed which actually contribute to the coverage of the newly created or modified stuff?
Yeah, I think what you're describing is pretty much test impact analysis, which is also different analysis. I think we have a workshop coming up for that in a few weeks. So this is not part of test gap analysis, but in general, we also support running only those tests that actually cover changed code. So that actually are relevant for the changes you made. And as for test coverage on branches, so test coverage is basically merged into the branches. So if you have coverage on the main branch and then you create another branch from it, the test coverage is also included in that newly created branch.
Okay, thanks.
Okay, now there's one more question in the chat. Is it possible with your reports to see the test gap trend over time, for example, for release?
Yeah, maybe we can also look at that in the demo. We also have some charts that show how the test gap developed over time. I don't have anything on the slides right here, but yeah, maybe we can take a look at that in a minute.
Okay, I guess that's a perfect lead over into the demo. So I would jump at that chance and let's continue with this part.
So I will take over. I'm Andy. I'm working on Fabi's team, helping customers to set up test gap analysis, and I will do a short live demo. So I'm sharing my screen right now. You can see my screen now?
Yes, that's good.
Okay, so for a short live demo, we also need a system under test, which one we want to test. And I have brought Digital Bank, which is an open source digital banking application written in Java. And it pretty much looks like a normal banking application, which we will see later on when doing the tests. For the first step, I will jump to TeamScale. So I'm right now running TeamScale locally on my machine for this demo. And TeamScale is a web server application with a web UI where you can log in. And after logging in, I'm redirected to the dashboard perspective of TeamScale. So some short introduction to the web UI of TeamScale. We have this right here, this main area right now showing the dashboard perspective. We have some dark navigation bar at the left side. For all the different perspectives, TeamScale is providing, for example, the activity perspective showing something like a git log output, or some static code analysis findings, our perspective for test gaps, where we'll jump later on, and something for configuring all the projects. Besides that, we have some menu bar up here, where you can select your project or the branch, or do some personal account settings. Right now, we want to look at this test gap tree map, which we have already seen before in the presentation many times. Now we have TeamScale up and running, and so we can also interact with this tree map. For example, I can open my method and jump into it right here. Then I'm redirected to the method history view, which basically shows a history of the method, in which commits it was changed. We have the same here for the issue history. So if our issue tracker is connected with TeamScale, I see here also in which issues this method was changed or affected. And I can compare this method. For example, right now, I'm comparing it with the baseline where it was last tested and with our untested modification we have. So we can see that there was some code refactored and into a method. And I can further jump into this and see the code of the last version of the method. And here I can also see the line coverage. TeamScale is provided with line coverage here. So I can see that this line was covered and those red lines were not covered. What we want to do in our scenario now is to test an issue. As Raphael mentioned before, we have here our issue test gap perspective, which lists all the issues we retrieved from our connected issue issue tracker. And now we see that we have some issues in progress and that we have some test gaps for these issues. We want to focus on this issue here, prevent deposits smaller than 0. So I will jump into it and we have a more detailed view of this issue. For example, I can see in the creator, the assignee, some description, which is retrieved from the issue tracker. What we want to now do is focus on this test gap tree map here. So we see again a tree map as we have seen before in the dashboard, but now only the relevant methods for this issue are shown in the tree map. We can see that one is already green, which means executed after the last modification because it was run by some unit tests. And we see that we have 2 yellow methods here and 1 red method, which means they were changed or added, but not tested yet.
Andreas?
Yeah.
There seems to be some issues for some of the participants that they cannot see your screen share. Can I ask you to just quickly stop sharing and reshare again?
I will try.
So sorry, everyone. I guess now your Zoom is jumping from and to full screen. I hope that's not too much of a disturbance. But since there's a number of people who are apparently not able to see the demo, I hope you can bear with this. Okay, so I hope this fixed the issue for all of you. Andreas, sorry for the interruption. Please continue.
No problem. So for everyone who was not seeing my screen before, we are now in the issue detail perspective, seeing all the information we get from the issue tracker. And we have here our test gap tree map, as already seen before on the dashboard or the slides. We have 1 green tested method after the change we made in this issue, and we have 3 methods here that were not tested yet. And we want to test now this this issue because I'm responsible for testing by reading the description. This issue should prevent depositing negative amounts, which would be equivalent to a withdrawal. So we want to do this right now, test if we can deposit negative amounts. For that, I am starting up my local test machine running the application. This will take a few seconds. Basically, what's happening right now is that we are building this branch which the issue depends on, and started with our profiler attached to it, so that we can record our test coverage. The application is already built now. It needs a few more seconds to start up. And it should be there right now. Yeah. So this is our digital bank application. I am logging in with my test user now, and yeah, we can see some layout pretty similar to TeamScale. And what we wanted to test is to deposit a negative amount. So I'm selecting here some account and try to deposit a negative amount. And yeah, that's not working. We get an error message here. That's basically what we want. So I will stop the test environment. Now I can also jump here to the activity perspective, and we are already on the right branch, and we can see that the test coverage I recorded right now was already uploaded and processed by TeamScale. So when jumping back to the issue, I also see now that we have tested 2 more methods, but there is one more which is untested. I could now click on this method and jump into it, watch the code, or I am just asking the assignee of the ticket what he did, or what he did according, or what he did more than preventing depositing. And he said that he also refactored the withdrawal method, and that it should also not be that we should also not be able to withdraw a negative amount right now. And as this is a pretty basic and often used function in a banking application, we also want to test that. So jumping back and setting up my test environment again, I will now test this as well in order to get this method here also green. It takes now again a few seconds for the application to start. And it should be up in a few seconds, and we can test. Exactly, here it is. So I'm logging in again. Now I don't want to deposit, but withdraw. I'm selecting account, and I'm withdrawing some more money because when it's not when it's not working as expected, I'm now pretty rich. So we should prevent this. I will stop the test environment, jump back and stop this here. And I would now talk to the assignee that he should fix this, because we can't give this into production. Now in the background, our manual test coverage is uploaded again. So I can jump back to the test gap perspective and the issue perspective, and we see that all methods are green. So what we are seeing right now is that we have tested this, so everything's green, but there is still a bug in it. So everything green does not mean that there is no bug in it anymore. What I'm doing now is applying the fix. So jumping one commit ahead, because we have already prepared this. Jumping here back to the activity perspective. So we see now that TeamScale is analyzing this new commit we have just made. And we can also see it here. And when jumping back, we see now that the withdraw method is yellow again. So as a tester, I would now normally test this again, that it's really working. But I guess to save some time and everyone knows what would happen, we would test it and it would work, of course. We stop this right here. Are there any questions?
So as of now, I don't see questions. Unfortunately, there was a lot of talk due to some technical issues for some of the participants. It did resolve for most, but unfortunately not for everyone. Very sorry for this. Apart from that, do we have any questions regarding the content of the talk specifically?
Maybe one question about using of the team scale. For example, if you would like to start a free trial, how does it look like to use it? Because I saw the how much you need to pay for usage of this application, and can we use it for free, for example, a few days to check or weeks to check how does it work? What's the policy of that?
Maybe I'll jump in. Yes, you can evaluate for free. We have two modes. Either you download a license from the website that runs for 3 months, I think. Then you can just go on by yourself and also contact our technical support if you have issues. But if you have like a more complicated setting or you want additional help, then we can also do a pilot project together with you where 2 people from us help you set everything up and help you make the most out of the analysis in your setting.
Okay,
and
thanks.
just contact us.
Okay, then we have one more technical question in the chat. Is it possible to track the manual testing for native mobile apps or desktop apps?
Can I also answer that, Andy? Is that okay?
Of course, yeah.
So for mobile apps, we don't have that much experience. In theory, it's possible, but we haven't done it very often yet. For desktop apps, it's actually no problem at all. We've done it quite a lot of times, and the profiling works the same as for example, web applications like we've seen in the demo.
I think then I have a question that is following up that one. Because we have a desktop application that is using the client server model. Do you have any experience with that? So we have a click once application and we are doing automated UI tests on our testing clients, but of course they don't know what the server is doing in the background. So do you have any experience with that?
Yeah, so like a fed client and a server backend for that.
Yeah.
We have several customers that have the same setup, and basically what you do is you record on both sides the test coverage. So on the server to see what happens on the server while the tests are running, and on the client to see what is happening there, and then upload both coverage reports to TeamScale, and then TeamScale automatically combines it. Of course, you need to import the source code for both sides as well. Sometimes people have the client in a different repository than in the server, but TeamScale also supports putting both repositories into the same project, and then you can get the combination of everything, and because you want the overview over both parts, right?
Okay, but I guess then test impact analysis in your next workshop would be more difficult because 8 clients are executing on the same server some tests, and then I guess we can't know from which test the calls are coming.
Exactly. In that case, you would have to serialize the different clients so you don't interfere with each other on the server side.
Okay, good
That's
to know.
Only a limitation for test impact analysis, not for test gap analysis.
Yeah. Okay, thank you.
Then there's one more question in the chat. Is there the possibility for training? So I guess getting people on board.
Sure, we can also train you. So I think the first step is always evaluating it to see if you actually get the benefits that we claim. in your setting. People usually want to see that first, and then afterwards, when you see that it helps you, then of course we help you train people to use it properly. Our goal is always that you don't have to spend a lot of effort on your side to make the most out of the analyses.
Okay, then right now we're out of questions again.
So if you don't have any more questions, I will jump to the next slide. I've just shown this for a Java application, but that's not only possible for Java, but for much more programming languages which are listed on the slide. So if you're interested, come talk to us after the talk, and I will hand over back to Fabio.
Thanks a lot. Steal the screen sharing. All right, and we come to the last part of the presentation, which is about a cost-benefit analysis that we did for our customer MunichRE. Because MunichRE is the customer that has been using the test gap analysis for the longest time so far, and they wanted to know, after several years of using it, what benefits did we actually realize from the analysis. And answering this question is rather tricky, because what is the main benefit that you get from test gap analysis? It's less production defects. And that's actually very hard to measure, because we're trying to measure something that didn't happen instead of measuring something that happened. So we had to dig a little deeper. Fortunately, at MunichRE, if you remember, we did this study that I showed in the beginning, which we did before they were using test gap analysis. So we had both data from before they introduced the tool and afterwards. And the comparison between the two allowed us to get to some results here. And now the key facts you need to remember from this study are that over half of the code changes remained untested, and it's 5 times more likely that a bug appears in these untested code changes, so in the test gaps, than in the rest of the system. Now, how do we approach this? So what we know is that if we want to know how many bugs slip through our testing efforts and make it into production, then we have 2 parts of the system. So half of the some of the code changes are being tested with the tests that we have, and some are not. And we know from the study that before MunichRE used test gap analysis, half of the code changes that they made it into production completely untested. And with that, of course, also all the bugs that were in those code changes. For the other half of their code changes, we know that the likelihood of production defects in that half is much lower than in the other, because we ran some tests and those tests found most of the bugs. And it's 5 times less likely. So if you have 5 bugs over here, you'll have 1 bug over here that still makes it into production because it slipped through the testing. So that's an additional 10% of bugs that make it into production. So in the end, 60% of the bugs that were in the system at the time when the testing started also made it into production before MunichRE was using test gap analysis. We can do the same thing with the data that we have from now that they've been using test gap analysis for several years. And we need the same numbers. So what is the test gap now? They actually use it for several dozens of applications now, the test gap analysis, and we looked at all of them. And to be very conservative in this study, we took the worst number that we found. And the worst number for them was 10%. So 10% of their code changes are still completely untested. So all the bugs that are in there also make it into production. For the rest, still some bugs are being found by tests, the majority actually, and some slip through. The same still holds. The ratio is about 5 to 1. So of the remaining 90% of code changes, 20% of the bugs slip through. And that makes 18%, and together with the 10% from the test gaps, they now have 28% of the bugs that were in the system at the time the testing started that also make it into production. And if you compare the 2 numbers, that's a reduction of about half. So this was a really cool result that we got here. So cool that MunichRE actually agreed to present this together with us at OOP a few years ago. And we were very happy about that. And they continue to use test gap analysis because of that. Now, of course, these results are very MunichRE specific. So we can't promise that you get exactly the same results on your system, but we have seen similar numbers at other customers as well. So I think that's a good closing words. So in the interest of time, I'll stop now, but we still can take questions afterwards, and we will also do the breakout room afterwards. And don't forget that in the end, you'll also get a poll where you can tell us how you like the talk and which parts we can still improve. We'd be very happy if you'd quickly answer that. So thanks a lot for participating. And before we go over to more questions and breakout rooms, a little bit of advertisements for some other talks that we have. The same talk that we had today we'll also do in April, but in German. So if you have more colleagues that you'd like to invite or people who would prefer to talk in German, then feel free to forward this to them. You'll get the slides afterwards with the link. And then we also broached the subject of test impact analysis. So how can we get faster feedback if we have a very long running test suite, which we will do 2 workshops on, one in German, one in English, in March and in June. So if you have rather long running test suites where the test suite takes hours, days, or even weeks, and you feel the pain for that, then feel free to also join one of those workshops to learn how we can help you there. And final word, if you like the talk and you would also like to inform your colleagues about it, we are also happy to hold the same workshop for you at your company. And this is also usually an opportunity where we can go into much more detail on your specific scenario. So if you're interested in that, then feel free to contact us afterwards, and we'd be happy to hold the same workshop for you as well. So thanks a lot. And then I would say we conclude.
I have a short question.
Oh yeah, sure.
I mean, we used it in our Jira tickets in that sense that we have a block which states test information, right? Mm-hmm. There it states the project name, the findings balance, and the test gap. And to me, it was until now not clear, and it's still not, to be honest, what this percentage mean. I mean, test gap, does it mean there is a gap of this percentage in code, or does it mean that 100%, for example, now of the code is being tested? Or I'm not sure how this is being displayed. Yeah, because yes, I've seen that, but in our Jira it looks different, and therefore it's not marked with any color, it's not marked with anything, it just states the percentage. And if I click on it, which is also the next thing, it opens up team scale. But then in there, I don't have any really information. It just states that this activity and gives me a summary of the ticket, which I already have in the ticket. So yeah, it's a little bit confusing, to be honest.
All right, I think there's 2 parts to answer your question. One is, I think for the very specific things about how it's set up for you, we'd probably better do a separate screen sharing afterwards where you can actually show me. And then we can go into that. So feel free to contact me about this afterwards. And in general, what we show in Jira is the same number we also show in the tickets. And it means that for the code that the developer changed for that ticket, for all the methods that they changed, how much % of those methods have not been executed during tests at all. So 22% here means that 22% of the methods are still red and orange. And these are only the methods that were changed in the context of this ticket.
Gotcha. Okay, so the higher the percentage, the less code was tested.
Exactly. So ideally, you want
or was run through. Yeah, got that. Okay, thank you.
You're welcome.
There's a question bringing up a topic from before. Thanks for pointing that out again. Maybe we can use the demo to show a test gap trend at this point, because we have some more minutes left. So,
all right.
Andreas, can you rejoin? Maybe? Yeah.
Or I'm not. trying to grab the screen.
Awesome.
So you should be able to see my screen now again.
I do see it. I hope everybody else sees it as well.
So that's that's basically what you can see in the trend or history of the test gaps. So you have a pre-map down here with all the methods we watch in the selected time span, and we have here our trend for the test gaps, as it's only a demo application. It will most probably look differently for a real application, but I guess you can see some first insights how this could look like, and you can also like zoom in and see some more differences when some test coverage, for example, is uploaded here at this point. Does this answer the question, or should I show some more details?
So thanks at this point, while we wait for more feedback. Yes, thanks is the answer. So I guess we answered this question. Are there any more questions at this point? Yeah, there's one coming in. Is there the possibility to bulk gray out trivial untested changes, like bulk name changes across the software, swapping positions of variable initializations, or other non-stability breaking changes?
Should I answer?
Yeah, Fabi, go ahead.
It's an excellent question. We didn't touch on this in the talk, but this is actually done completely automatically. So we have a so-called refactoring detection, which detects these non-stability breaking changes. So things where you change the source code, but it doesn't change the behavior of the program. And of course, this is a very hard problem. So we are not able to detect all of the refactorings that you do, but we detect the most important ones in high-level languages. It's usually things like you rename one package and the package is used in 70,000 locations. Then you don't want 70,000 test gaps because the renaming tool probably does this correctly. And so TeamScale detects this and filters out these changes. And in addition, we also filter out very trivial code, for example, trivial constructors that just assign to fields, and trivial getters and setters, because this is also usually not code that you actively want to test. So we try to reduce the amount of spam, if you want, in the test gap analysis as much as possible, so you as the human get to focus on just the really important code changes.
There's an okay thanks in the chat, so I guess you answered the question perfectly well.
Thanks for the question.
At this point, I again say there's no more questions, and I say that slowly in case there's more questions dropping in. No, honestly, I think we're 2 minutes to the end of the workshop, so let's call it an end at this point. Thank you all very much for participating and for all the interaction in the chat. We'll open up the breakout rooms in case you have individual questions to the speakers. They will now each join one separate breakout room, and you can feel free to join them and ask your questions. And if you're leaving us at this point, again, thank you very much for participating. I hope you took something from the workshop today. We'll send you, because we had that question before, the recording and the slides automatically, so you don't have to do anything here. And yeah, I hope we see you again soon. And since most of us are in the same time zone, I guess have a good lunch. Bye, everyone.
Bye-bye.